We find that the best systems that work effectively are those which are transparent, which are predictable, which are science-based and flexible, and it's very important that the regulations reflect the product development cycle. In other words, it's not particularly advisable to be doing a full-fledged environmental risk assessment for products that are in the greenhouse or in the confined field trial. It's also important that whatever policy is in place meets the local tests, that local institutions are able to afford and meet the demands of the policy. It's important that these policies are reconciled with existing laws such as seed laws, plant variety protection, food safety, etc., and that governments need to factor not only into their research dollars the money for research, but also the money for effective biosafety policy and regulation. Communication is also important, particularly for policymakers to both enable and communicate the results of their decision-making process. And we found that that is the best way to build public confidence in the process, and it's important to be very strategic about outreach and communication, be very consistent, and to begin that those approaches product development process. To that end, we've been IFPRI called net mapping, which was developed by Ava Schiffer, who was a postdoc at IFPRI. It's a social network analysis tool, and PBS has been one of the first to pioneer it as a problem-solving tool, particularly in the area of biotechnology. And it can provide a lot of direction for identifying policy constraints and processes, targeting audiences, understanding what the key messengers are, who the messenger should be, looking at the strategy and tactics for effective policy, decision-making and implementation, and also give some idea of timing. This just shows the difference between net mapping and traditional stakeholder mapping, which some of you may be aware of in the room. And net mapping is really, what I like to say, traditional stakeholder mapping on steroids. It not only shows you the broad groups of stakeholders and classes of stakeholders that are interested in a particular issue, but it also shows how they are connected to one another. And that can be a very powerful tool for understanding what the positive pressure points and the negative pressure points are around any given issue or policy. So we have been using net mapping quite a bit in PBS to guide our work in the area of biosafety policy formation. This here shows you at the end of the day what one of the maps looks like. The larger the circle, the larger the level of influence. And as you can see, you get a very nice pictorial diagram of various groups of stakeholders and how they're connected, and that's, again, another positive and a plus for using this type of methodology. We've been using net mapping for biosafety in Africa for several years now, and it's been helpful for us to work with our partners in Nigeria to help figure out a pathway for the passage of the biosafety bill in Nigeria. In Ethiopia, we used it to help define a pathway to create a progressive discussion about biotechnology in the country. In Uganda, similarly to Nigeria, we are using it to inform what the likely process is for the biosafety bill's passage, and that's also resulted in the formation of a very active and tightly organized coalition. And in Malawi, we used the technology to identify the constraints that were impacting the approval of the confined field trial for COP. As a result of not only net mapping, but the other work that we do, we, PBS, working in partners with others such as ABNI, ISA, Africa Bio, etc., have seen some really remarkable turns of events with respect to biotechnology in the last several years. The biosafety bill has been passed in Kenya, and it's now in the arena of working on the implementing guidelines. Ghana just passed their biosafety bill and is poised to consider their first confined field trial. Uganda's bill is in process. Nigeria's has been passed, but we're still waiting for the presidential decree. But meanwhile, field trials are reaching a mature stage for cassava and cowpeas. Malawi, as I mentioned, just approved their first confined field trial. That will be taking place either at the end of this month or early December. Of course, Egypt is revisiting their biosafety framework and their bill under the direction of the Ministry of Environment. And respect to COMESA, there is a very significant regional harmonization initiative which is underway and is looking quite promising. So there are many examples of good progress around biosafety in Africa. More and more confined field trials taking place every day, recognition for the need for good outreach. Many service providers are working more collectively together. African scientists are exerting their influence on the regulatory systems. Developing country farmers in Africa are certainly exerting their influence as a technology pull versus push. And there are a number of harmonization initiatives underway and good political leadership coming from such countries as Burkina Faso, Kenya, Nigeria, Ghana, Malawi, etc. However, there are still a number of things to focus in on and spend a little bit more time thinking about and working on, because for a majority of African countries, policy still remains heavily focused on risk, has lots of non-scientific elements in it, things which are an obvious disincentive for the technology's development, such as strict liability clauses. And at the process level, there still a need to do a better harmonization between ministries in terms of what their respective roles are, deal with the issues of limited operating budgets and the fact that many times biosafety laws are not reconciled with existing laws. The capacity, while growing from the efforts of programs like ours, as well as many others, could still be increased because in terms of lack of capacity, that creates a knowledge vacuum, particularly in the political level, which creates an opportunity for loud voices and negative influencers. As I mentioned, there are many service providers who are working in the area of biosafety in Africa, but sometimes we are conflicted in terms of our message or doing similar things, so there's a lot of redundancy and crossover. And in some cases, there are opposing points of view represented depending on what donors are funding the project. And then, as I mentioned, from a practical standpoint, while there are a lot of confined field trials, we seem to be stuck in a bit of a treadmill or a rut and not able in many countries to move from the confined field trial status to the commercial deployment status. So in summary, I think the tide is turning. I do have reason for optimism here in Africa, particularly on the biosafety front. Many more countries are exhibiting leadership and are being quite vocal in the need for the technology and the need for rational biosafety systems. The technical capacity is definitely increasing, as are the numbers of products which are either being released or are in the pipeline. But there are still too many cases of policies on paper that haven't been brought to practice. And in more cases than not, the regulatory systems here in Africa can be quite expensive, time-consuming, and often not science-based. And this is a result of the continued lack of capacity, lack of resources, lack of accurate information, and in some cases, lack of political will to move forward. So I would like, with that summary, to go back to my original premise, which is that biosafety is a key rate-limiting step in the adoption of the technology and requires additional attention in order to bring the benefits of the technology to a greater level here in Africa. In terms of how to move forward, I think those of us who've been working in this area need to recognize that we need to assist countries in doing a better job of interministerial coordination, because oftentimes that's where the dialogue breaks down and that's when the system breaks down. And we also need to think about non-traditional ministries. We tend to focus on agriculture and environment, but there are others that play an extremely important role in how this technology is regulated and deployed, such as justice, trade, and ministries of planning. I think there are a lot of people across the continent who are doing great work and who have had a really good increase in terms of skill set, but oftentimes they tend to be working in isolation, and forming a better network between regulators across the continent would be optimal, I believe. Technical harmonization, particularly at the regional and sub-regional level, important thing to continue to pursue. Strategic outreach and coalition building to support the decision-making process. Make sure that we're looking at biosafety in the context of existing laws that are on the books. dealing with the advanced issues such as staph traits and insect resistance management, doing a better job of, among we service providers, of coordination, spending a bit of time speaking with and perhaps having dialogue with the African Union to better understand what their position, particularly from a regulatory perspective, is with the technology, focusing more particularly on the issue of women and gender, because it is, for the most part, women who are growing most of the crops, and yet their voices have not been strongly heard around either the debate or even within the policy corridors. And finally, I think the most important thing is to reposition the biosafety protocol for what it was intended to be originally, which was a protocol looking specifically at biodiversity and not the de facto regulatory framework that it has become. So, from my perspective, the good biosafety decision-making which is taking place here in Africa can facilitate a positive role for biotechnology in Africa's economic future. And with that, I'd like to thank you, acknowledge my colleagues at PBS, IFPRI, ABME, the Danforth Plant Science Center, and ISA for their contribution to my slides. And should you have any questions to follow up with me on after my presentation here, my email is there, as well as the PBS website, which you can visit to learn more about the kinds of things that PBS is doing in Africa. Again, thank you very much. Sorry I could not be with you in person, but I wish you a great conference. Good afternoon. It's a pleasure to be here with biotechnology, and I'd like to first of all thank the organizers of the faculty.
Sorry.
Thank Dr. Nadia for standing for this. I want to thank the unit for that presentation. We are, with my co-chair, Professor Mohammed Suleiman, we decided to have all the questions at the end of the presentation, and we're having 4 other presentations now. So you bear with us, and please remember to write your questions down so that we discuss at the end of the presentations. Over to you.
Thank you very much. I would like to introduce Dr. Margaret Colombo, the director of ISAA African Central Kenya. Her talk will be about communicating biotechnology and biosafety experience from selected African countries. Thank you very much. Please try to finish in time.
20 minutes.
20?
Yeah.
20 minutes.
Thank you, Chairs. Once again, I will be making this presentation, communicating biotechnology and biosafety, and I also want to recognize some of our team members whom we've been working with in Africa in trying to enhance informed knowledge sharing and policies, including Professor Kenya there, the COMESA team, ABNE, and others. Now, I'll start with just one statement that has been made several times about how sad it is that scientists are spending so much time in the labs, but when their products get out there, the society rejects or the public rejects. And I think one of the major gaps or the missing link is that scientists many of them do not make that extra effort to make their work be seen to be relevant to societal needs. So today we are going to look at communications and just giving some ideas on how we can approach this difficult area where there has been a lot of debates and polarized views about the benefits and the risks of the technology. Now this is the outline of my presentation. I'll very quickly look at why we want to communicate, the what of science communications. In this case, taking biotechnology and biosafety to be part of that science, then preparing for effective biosafety communications, and lastly, share with you some of the experiences we have had in ISA, working in partnership with others in the region and outside. Now, in terms of why communication is so important, precisely because we are finding the relationship between science and society, changing very rapidly with the access to information and communication technologies. It is very easy now to make an inquiry about anything that a scientist is doing in anywhere in the world. And so this makes it more essential for us to be continuously engaging our public or our consumers. And then another very big challenge that is happening or has been happening with this technology is it has become very difficult to define who an expert is. So we have pseudo-experts or pseudo-scientists influencing the way policies are made in Africa, in most of our developing countries, and indeed even in developed countries. And so when the media, for example, communicates with a professor, it does not matter whether that professor is in political science or is in theology or in which area. The fact is, it is a professor, it is an expert, and they'll be quoting an expert's view or an expert's position about this technology. And this is precisely what has happened in Kenya today. A number of, some of our politicians may have consulted some pseudo-scientists or people who are really not in this area of expertise, but the fact that they are considered to be top scientists in the country, top competent authorities in their areas, then they contribute to policy decision making. At the same time, you're finding society wanting to understand better and better the scientific process of inquiry. Unfortunately, they consult the same pseudosciences that we are talking about, which puts a question mark on availability of scientists to engage with the public. And all these scenarios have created what you'd call, a kind of an equilibrium where on one side there is a group that thinks or that positions the technology as a monster that is going to finish the world, and on the other side, die-hard proponents who position the technology as the only solution to the challenges facing global community, and especially in the area of feeding the world. There's no answer to that question, and as we communicate, it is important that we moderate the messages, the kind of messages that we communicate with the public, because again, based on the interactions that the public have with different experts, depending on who you interact with, then you form perceptions. And yesterday we spent quite a bit of time with Alan there, just giving us about the many misconceptions that this technology has been faced with. Now, another major contributor to the misperceptions and misinformation about this technology is that the world, through information communication technologies, has become very, very networked. And a myth or a propaganda or a rumor will pass very, very fast. For example, if you just consider, let's say you have a small center, maybe one or two people are based in some place. They could be based in Cairo, they could be based in South Africa, or even in the US. Within a fraction of a minute, you can be able to pass that rumor throughout the world. And within 5 minutes, you ring Burkina Faso, and they'll be telling you about a rumor, or about a fact, so to say, that has been generated from some expert report or some expert peer-reviewed paper or some journal. So basically, in a world where misinformation passes so fast, then the scientists or the scientific community also need to devise a way of becoming very well networked and coordinated, so that you are also able to communicate evidence or the facts about a certain aspect of the technology very fast because of this communication. Unfortunately, again, scientists are not really very good in networking, and I would like to congratulate Nagla and her team for really bringing this meeting to be, where the scientific community from different parts of the world can start interacting and networking to be sharing a lot of this information. Now, the mass media, much as they are very important component of the communication stakeholders, I think in this area they have also developed some kind of, very creative, I would say, artistic illustrations on the products of biotechnology. For example, it's not unusual to find this kind of representation in the newspapers. And you can imagine what that does to a farmer out there who sees this kind of illustration. We call it a fantasy or a fairy tale, or what, the imagination of the mind. Then we also know that most of the times media will report about the unusual. And I'm sure you are very much aware of this very common phrase that if a dog bites man, that is not news, because that is the usual thing. But, if a dog bites man, that's not news. But if a man bites a dog, that is unusual. And both sides of the coin, according to news gathering, may have the same weighting, but of course, the one that will sell news is the unusual situation when a man is biting the dog. At the same time, all these illustrations have created fear, mistrust, anxiety, and many times outrage about the technology. And in this situation, we say that all these issues are leading to what we would consider as communication difficulties, where emotions, we had this morning, feelings overrule facts. You have selective listening and hearing. Most of the times you listen or hear what you want to hear, mainly because of the way we have set our minds. If you set your minds that the technology has nothing to offer, you'll only hear that. Even when you provide the evidence, until the farmer grows the crop, it will remain as hearsay. Most of the times we tend to emphasize the negatives, mainly again because negative kind of closes in. We are more comfortable when you dismiss something than when you accept it, especially where there have been expressions of uncertainties or controversies. And so it is in these situations we say that we cannot not communicate. But now the challenge is, how do we enhance comprehension in a study or in an area as technical as genetic engineering and biosafety and all the other terms. And this emphasizes the important role of scientists becoming communicators or working with communicators to interest them in science so that they can be able to communicate about the science. So working together, the scientists and the communicators working together to have the science communicators. Now, many times, especially in this area of biotechnology, you may not even need to say a word. You only need to make a presentation or to have a structure. Now, this is a picture that was taken in one country that was conducting GM cotton trials. And when you look at the way the regulators have prescribed how a trial, a confined field trial should be, fenced. Now, in this case, although these guys here, you see here, their guards, they are having guns. Actually, they were not guarding the trial. It's because this trial was in prison land. But the fact that they are there and the community around see gunned guys around a confined field trials, that's already very big communication. It has a very big impact because then people start wondering, what it is that could be inside there that has to be guarded. So even the way we present the activities that we conduct communicate without saying a word. At the same time, now this is a picture. This guy here is actually our president, the president of Kenya, Honorable Mwai Kibaki. This picture was taken together with this guy here was then the director of the Kenya Agricultural Research Institute, which is the national institute spearheading research in biotechnology in Kenya. He was commissioning the first biosafety level 2 greenhouse in Kenya. And look at the dressing. So what does that kind of dressing tell you? When do you wear red? Yeah?